Hey gang. So you may be wondering, what is this degrees of freedom thing you keep hearing about? And why is it equal to n minus 1? At least why is it n minus 1 in the context of confidence intervals using a t distribution? So why that n minus 1 and why degrees of freedom? So here's a really simple example to try to illustrate both of those points. So let's just suppose that we've got some data set of just three numbers, a, B, and C. And let's just say that they average to something really simple. Let's say they average to 0. So we would say A plus B plus C divided by 3 is equal to 0. Or we can just cross multiply there the 3. That simplifies to that nice little condition. And the thing to notice is that at this point, any three numbers that satisfy this thing, that add up to 0, satisfy this condition about the mean that we had. So we can pick any three numbers that satisfy this condition regarding the average or the mean. The mean condition. All right, so that's all well and good. We have three numbers that we can play with. We are free to choose three numbers. Now, this was a condition on the expected value or the mean of this three-number data set. What if we had a second item of information? What if we were told that the variance of A, B, and C was equal to another nice, easy number for us to work with? Let's say it was 1, just for the sake of simplicity. What we'll see is that's going to constrain the set of numbers that we can choose from. So let me show you. First, let's just remind ourselves what the definition of variance is. It's the average squared distance of each point, A, B, and C, from the mean, from 0. So let's just write that out. That's A minus 0 squared, B minus 0 squared, C minus 0 squared. And we want to take the average of those three squared distances. And we said, let's just suppose that that average was 1. Now we can cross multiply this 3 as well, and then subtracting by 0 is, we can ignore that. So this statement simplifies to A squared plus B squared plus C squared is equal to 3. And now on the surface, it may look like we still have three numbers that we can choose, but we don't. Not when we have both conditions that we need to satisfy. And here's why. Let's just substitute this equation into this second one. In fact, let's simplify this thing first. So let's subtract off B and C from both sides. So that leaves us with this. And then let's substitute this A in for here. So what we'll get is negative B minus C squared, and then these two guys. And let's keep writing. We can simplify this. So this would be B squared plus 2BC plus C squared, just if we FOIL this guy. And then let's add the B squared, C squareds. And then simplify. So we can combine the B's and we can combine the C's. And this thing was supposed to be equal to 3. Let's not forget that part. So we got the 2B squares. We got 2BC. And then we got the 2C squares. And dividing both sides by 2. Now, what do we got here? So once we incorporated both bits of information, the mean and the variance, what we see is that we actually only have control over two data points, B and C. And which ones we called B and C was totally arbitrary, right? It's just 2 out of the 3 numbers. So whereas before, when we just had a mean equation, we could pick any of our 3 numbers, and n was 3 here. Once we added that second condition, we could only pick n minus 1, right? We could only pick 2 numbers, B and C, that was to satisfy the mean and variance conditions. So there you have it. This is a simple explanation for what we mean by degrees of freedom, meaning how many numbers can we pick, or how many numbers can we determine, and why it's n minus 1 in our context. And it's n minus 1 because the addition of a variance restriction basically eliminates our ability to pick one of our data points. So that's it. That's why it's degrees of freedom, and that's why it's n minus 1. Thanks for listening.